Cool. So, actually, let me just get my presenter view as well. Cool. Thank you. So, okay, the presentation I'm going to give you today is called Agents Building Agents. And the subtitle is How We're Bringing Agents to the Hub to Democratize the Hardest Problems in AI. And the kind of the motivation for this presentation is from an observation that I'm seeing across the open source AI community, where people are inspired to take on even harder problems than ever before, right? Like, it doesn't seem to be that people are tackling the same problems that they were tackling before and just saying, all right, this problem is now significantly easier than it was before. Like, what I see from developers that I speak to is that they are searching for harder and harder problems and trying to solve those, which is super inspiring. It's really cool. And so that's what I'm going to go through. The kinds of problems I'm talking about are training LLMs, writing CUDA kernels or kernels for AMD or whatever kind of hardware it is you want to run models on. And people are really going like bigger in scope and also kind of deeper in terms of engineering and in terms of hardware. So what I'm also going to do is share as like a methodology for doing this that we've worked with across a set of projects here, and they're basically summed up by these blog posts. I'll share these with you again afterwards, but in this one we train AI models using Unsloth. In this one we write custom CUDA kernels. In this one we write more custom CUDA kernels, this time using a library for it. And this one we train more models. And there's a series of these blog posts, and this is the methodology behind all of those projects. The methodology is an agent does a hard task. So you iterate slowly with the agent through this very hard task. So for this to work, you need to be at the upper bounds of what an agent can currently do. So it's trying something, it's failing, you're prompting it, it's failing, and you're taking it through to the end after a number of after a trial and error process. From that process, the thread, the trace, you extract a skill, and the skill makes that agent do it zero shot, ideally, or um, makes other agents even better. So maybe you can take this hard skill from, say, a Opus 4.6 model, and you can take it down to a Sonnet model or even a locally running model. So that's the kind of TLDR that I want you to take away. This basically trying these very hard problems on agents and then using skills to take the implementation of those hard problems down to other agents, either so that they can one shot or that you can use a cheaper or smaller model. Yeah, I think that in this context, we're all fully aware of how popular coding agents are at the moment. So I won't get too far into that. The only thing I'd say is this what I think the previous presenter was also clarifying was this perfect combination between MCP and skills. Some of the friction that I think a lot of people were experiencing last year around MCP was a lack of skills really. The lack of like formalized instructions about how to use an MCP. That a lot of prompts were shared in documentation and kind of it was hit or miss how much performance you could leverage out of an MCP. And a lot of that has been locked down by skills. Okay, so what are a skill? I hope this isn't repeating anything for the audience, but the simple way that I like to understand them is that they are file-based context. I think that that's probably oversimplifying them, but that's often quite useful, right? And so because they're a file-based discovery, we can do the same kinds of things with them that we can do with all the other files that we use. For example, push them to repos and kind of version control them and share them in the ways that we share files. So they leverage all of the inherent powers of a file, which is simple and easy to deal with. They have three main elements to them: discovery, activation, and execution. Discovery is, in simple terms, that they present a name and description to the agent, and the agent can elect to use them or not. If the agent elects to use them because their description is relevant to the instruction that it's being given by the user, it will activate them and certain parts of their context. So it could activate the skill.md, the homepage of the skill, or it could activate certain references within the skill, and then it can execute components within the skill. So it can take a script out of the skill and run that. It can also regenerate the script and execute that generated script. What does the structure look like? In its simplest form, it's a directory with a skill.md in it. That's the requirement. And within that skill.md, it's required that it has a metadata at the top that says a name and a description. After that, the rest is optional. The next relevant part, I would say, are the scripts. And so these are scripts in really any language that the model is capable of doing, the harness is capable of using. And that can be scripts that allow the model to do the kinds of things that are described in the skill, right? So if it's like a data processing skill, it would be a data processing script. The references are examples of how the agent should perform certain tasks. Now, I think it's the next slide where I say this, or maybe it's later on, but for me, one of the best ways of understanding how a skill works is to say that it takes a task and makes it few shot. So it takes a zero shot task and it makes it few shot. Now, that's not entirely correct because obviously the model might have had some kind of examples in its training. But if we understand it like that, what we want to do is to give the agent examples of the tasks that it's doing. Now, if we were to do that using a traditional prompt or an agents.md, this would be very verbose and we would use up too much context. But we can put them into references, we can give these examples, and the agent can load them in when it needs it. So that's the kind of progressive disclosure, one of the main unlocks of skills. The next comparison that I want to go to is skills versus agents.md. So I'm actually a really big fan of agents.md. So I mean, I maintain the skills at Hugging Face and I'm fully into skills. But I think that often with skills, we've gone a little bit, there's a tendency to forget the power of agents.md. So in this slide, I just want to clarify that agents.md has a context that is always added to the model. Skills are progressively disclosed, right? They're discovered when the instruction is relevant to them. So that means that if you use a skill for a rule, the rule will only be in the context of the model if the model has decided that it's relevant to the instruction. And an example for this, you could go and check the Transformers repo. I opened a pull request a few days ago and it merged it today, where I wanted to define some strict contribution rules for agents. So that agents would always look up issues before opening pull requests. And so I put this in the agents.md. If I had added a skill for contributing to transformers, for example, that would be contingent on the agent deciding that that was relevant to the current process. And for that example, I didn't want the agent to decide. I wanted this to be a hard and fast rule that was always obeyed. Now, for many other things, for processing, for defining a process, for defining best practices, improving performance, and reducing tokens, skills are great. For best practices, there are some that you might want to put into agents.md if they're kind of hard and fast rules. And in some cases, yeah, you can still reduce tokens with agents.md if you've got kind of use case in your project that you want it to always follow. Okay, as I said before, skills really unlock the power of CLIs and MCP. And I wrap this under like easy skills. And so at Hugging Face, what we're doing with kind of easy skills that really just supercharge existing CLIs is we're integrating them into our CLIs. We've done this in the HF CLI, which is for the hub, TRL CLI, which is a reinforcement learning library, the kernels library CLI, which is for writing CUDA kernels, and the Gradio Python application. And they each have a command that's roughly like this: HF skills add parameter Claude or Codex or OpenCode. And what this does is it just writes a skill directory to your project. So if you're using one of those CLIs in a project, this is the best way to start it off. A bit like with your UV init or whatever it is you do, we just write them to the project directory. And we're finding that this is one of the best ways to share skills because you can update those skills for that project as you go. And in general, they're quite simple skills. They're really just condensed documentation. Beyond simple skills, we now have complex skills. So things like training models. These are the kinds of things I was talking about at the top of the presentation. where we really take models to the limits of their abilities. This is the first one I mentioned, training LLMs. So we will say things like fine-tune a Quen model on the data sets, OpenR1 Code Forces, or the one that I showed earlier, where we fine-tune an LFM model. In this example, we can tell it to validate the data set, select appropriate hardware, set up tracking and monitoring, and we submit the job to Hugging Face Hub. Let's have a look at how that job went when I started it before. Cool. So it's actually finished. We had this job ID. So, okay, cool. We can have a look at that. Cool. There's an error on the job there. Let's see if any others started. Okay, these completed. So that one that I started actually failed out. I'll probably need to iterate through that. Okay, it wasn't authenticated. That's my mistake. Let's have a look at one of the other ones I started. Here's one here. Cool. So this one you can see worked. And we have a job that's trained on Hugging Face using an A10G GPU. Yeah, so I think there I probably should have included better authentication instructions. But in general, when you use these skills on Hugging Face, the best thing to do is just to do href login, and it will log in your environment, and then you can start your coding agent from there. So that's the example of the training LLMs. When we first implemented this, we actually ran it before Codex had a skills integration, and that's the dashed line. I think this kind of plot is somewhat interesting because it shows that how skills relate to token consumption. So in the first two examples, in the hard example, so the solid green line and the solid orange line, which are Codex plus skills and Claude Code plus skills, you see that the models immediately consume tokens on the horizontal, and they start with a higher score on the benchmark, which is the vertical, because they get these instructions to begin with. And that's the kind of takeaway of these hard problems, that you put these few shot examples into the context so the model has clear examples of how to do something, like a script, for example. The next example I want to show are custom CUDA kernels. And in this example, we took Claude and Codex and we used them to generate kernels for CUDA. So what we found with these is that we could improve RMS norm by 1.8, so 88%, and improve Quen 3's RMS norm by 94%. And we iterated on these for quite a long time. Some of these kernels took multiple hours to write. Some of them used sub-agents. So these are really long-running tasks, and in most cases, they improve the CUDA kernel performance. If you also go on GPU mode, which is a benchmark for GPUs so with an open submission format, you'll see that I'm on there quite a lot submitting CUDA kernels, and I'm regularly using this skill to do that. Um, and what we found was that this is at a certain point in time, like LM sys engineering was seen as like the last kind of sacred ground of ML engineering, and it would never get to a point where coding agents would write CUDA kernels. But actually, if you go on to GPU mode and you look at the submissions there, many of the submitters are now using coding agents, and many, in fact, don't have that much experience in writing kernels. And this is becoming a real unlock for the community to enter into this new space, which for us is super cool. If you're interested in kernels and you want to like kind of start off that journey, I would recommend these three blog posts: From Zero to GPU, a guide to building and scaling production-ready CUDA kernels, the other two as well. And I would also recommend this one, which I published, which is specifically about how to use the CUDA kernels that are integrated into the kernels library. Cool. So how did we integrate it? Just to give you a quick overview, we've used a similar kind of architecture in all of the CLI libraries. We basically write them into the library as with an agnostic directory named like skills. And then within the CLI, we use symlinks and we write them to the respective location that the user defines. So if the user says Claude, we write them to a .claude directory, etc. And we also allow them to write to multiple directories. We found that this gives the most like agnostic and open usage of skills instead of sharing them in a marketplace. And it puts them where they need to be so that the maintainers of the library maintain the skills, basically. That's the main motivation to have them there. This one had a set of scripts, like for example, for benchmarking, but mainly for writing the kernels and using them within transformers and injection, and many examples that specifically related to hardware. So hardware definitions for writing CUDA kernels can be quite verbose and detailed, and they're not something that we want to drop into context if they're not relevant. So for each hardware type, we had a different reference guide there. How did we get these skills to work as I wrap up? So to do this, we've used a library called Upskill. And what this library does is it generates a set of tests for the skill. They can be LLM judged, they can be simple checks, they can also be Python scripts, and it will test the skill with those tests as it generates a new one. And so we can get the LLM to go into a loop where it refines its skill and then evaluates its skill. And what we found was that in some cases, certain skills were reducing token consumption, and in other cases, they just weren't. And likewise, in some cases, they were improving performance, and in other cases, they just weren't. And it was a non-obvious relationship. If you look here in this example, Kimmy improved significantly, but and also reduced token consumption considerably. So you'd say, okay, that's a clear few shot example. Opus here got roughly the same score for roughly the same token consumption. So it might not be so useful to use that skill. Likewise, with Haiku, we can see a similar relationship. However, with GPT OSS, we can see that it actually reduced its performance and it used slightly more tokens. So maybe we need to refine that skill further. And the upskill CLI comes with uh, this kind of view where it will basically just test a given model with and without your skill, and then allow you to iterate on that skill to improve it. And as it goes, continue to evaluate on that skill. We've also got a new blog post coming out where we integrate this with DSPy, and I think that that will be the kind of the next step of where to go with upskill. Okay, if you want to try this out, go to this blog post. I've already mentioned it, but it's got an example of the demo that I just showed you with training. And the main takeaways are to use skill to improve performance, like not necessarily to define rules. And the hardest problems are perfect for skills, whilst easy problems might not need them at all, and you might be able to leverage the model's abilities, its inherent abilities. Cool. Let me wrap up there. The other one I was going to show you, but I don't feel like I had enough time, was this example where I SQL query the hub and I go to a specific data set. If you want to try that at home, I'd recommend installing the Hugging Face CLI skill and then doing a kind of SQL query on a data set itself, and you can query the rows within that data set, which is pretty cool.